Ethanol Production by Cameron Williams, Mark Gould, and Levi Bundy. Now, some of you may not know what ethanol is used for. Ethanol is used in a lot. Fuel, your gas in your car is made from fuel. The E and a number is ethanol percentage. It can be used in biofuel as well. It's also used in other fuel additives. It used to be used for rocket fuel back in the Second World War. Medically, it's used for keeping things clean, hand sanitizers, antiseptic, and specimen preservation. It's also used recreationally in this list of things and can also be used in alcohol, which we will touch on later. It's used a lot in chemistry. It is a universal solvent because it dissolves both polar and nonpolar. This is due to the molecule itself being both on different ends of it. It is also an organic precursor to a lot of other organic molecules, such as ethylene and acetic acid. Here's a simple process diagram showing how sugarcane and corn, or any other complex sugar, can be mashed up and fermented using amylase. After the fermentation, it comes out to the slurry. This is the upstream process. It is then in the downstream process using stripping and reacidification, and then molecular sieve for even more refining. The byproduct is left and used for animal livestock. How is ethanol made? The first step starts with the precipitation of raw materials, sugarcane, corn, or any other starchy crop. It's mashed, broken down into a slurry. Then it is tracked to see how much glucose it has using NIR spectroscopy, that's near infrared spectroscopy, or refractometry. The goal is to have a simple sugar concentration of 18 to 25%. It maximizes the microbial fermentation and minimizes the amount of unfermented sugars. How is ethanol made? Once the amount of simple sugars are there, the slurry is cooled to 39 to 32 degrees Fahrenheit, and then is transferred of centigrade to large tanks. An organism like yeast, algae, or E. coli is then added to the tank to ferment the slurry. Enzymes break down the simple sugars into ethanol and carbon dioxide. The ethanol content is consistently measured using that NIR technology. The limit for ethanol in this phase is 12 to 15% because the fermenting organisms will suffer from ethanol toxicity at higher level concentrations. Here, glucose is catalyzed by yeast to make ethanol and carbon dioxide. Now, the first step is a stripping column. Once the slurry gets in at 8 to 15%, it is then heated up from the bottom, and steam will push the ethanol up, and then the steam will recondense down. This process is usually done 30 to 15 times with different trays, and at the very top, you can get about 35 to 55% ethanol based on what the product needs. Heavier things will condense and get to the bottom, and we will have some liquid and some solid waste. Solid waste has a little bit of residual ethanol, but not enough to make the process bad. Distillage is then fed to animals and other biofuel purposes. The second distillation is reacidification columns. These are similar but very different. There are 50 to 100 of these perforated bubble trays down here. And it is very similar to the last one where steam will push ethanol up and the steam will recondense and fall back down. The trays have small pools of liquid that require steam to bubble through, and that pushes the ethanol through it. The ethanol at the very top can reach 96%, which is a very high concentration. If you need an even higher concentration of that, a different method is used. It is called dehydration using molecular sieves. For a plant that needs above 99%, sieves they are small little holes that will absorb water and nothing else. So only water can get into these sieves. That effectively dehydrates the ethanol solution and allows us to reach higher concentrations that we cannot get with distillation. These Z-Lite trays can be regenerated. If heated up, the water will be pushed out of the sieves and you can reuse them over and over and over again. The method for distillation cannot get above 95% due to the azeotropic effect, which causes the ratio in ethanol in water to vapor to be equal to that of the solution, meaning if you need above 96%, you have to use this process. What are the sugar sources? Brazil was the largest exporter of ethanol, and sugarcane is their most common feedstock. In the US, corn is our most common feedstock. A variety of different sugars can be used for fermentation and distillation of alcoholic beverages. A few fun facts. Brewing uses the same chemical pathways as commercial ethanol production. It can be more dangerous because of fermentation byproduct of methanol, which is removed in the stripping column process in commercial plants. Most starchy or sugary fruits and vegetables can be fermented to make ethanol. Commonly used is grapes for wine, barley for beer, rice for sake, and apples and pears for cider. Once it can be fermented, it can be distilled over and over again to get higher spirits. Here's a fun little ethanol crossword. Pause the video if you wish to complete it. And here's the answer key to it. Have a great one.